Okay, hey guys, we are going to go ahead and video the dissection from yesterday. We're going to start with a live worm so you can see some things about him. First of all, you notice he just righted himself and he put the dark side up. That's his dorsal side, that's his back. And then also you can kind of see how he's moving here. He's got a hydrostatic skeleton. He squeezes his segments forward with his circular muscles and then pulls them up with his longitudinal. So there he's squeezing himself forward and then pulling everything else to catch up. And then underneath he's got some little hairs called setae, and they help anchor him while he's trying to move. You also see this little clear colored band right here. That's called the clitellum. And the clitellum is part of his and her reproductive structure. Worms are hermaphroditic. They're both male and female. And what they do is they climb up next to each other and they sort of use the clitellum, that little band right there, to make a mucus ring. And then they sort of pass eggs and sperm back and forth inside that, and they pull out. And then the mucus ring from the clitellum sort of falls off and becomes a cocoon. You can see the movement again. This is an invertebrate, phylum Annelida, and there obviously are no bones there, no backbone, but he's able to move himself forward by squeezing himself forward. Okay, so I'm going to go ahead and euthanize this worm, and so we'll use him for our dissection today. Okay, we've got the worm pinned now, and you can see the anterior end here, posterior end here, and the dorsal side is up. You can see this is the dorsal side because it's darker, and it's pretty common in animals that the darker side will be the dorsal side or the back. And again, these anatomical arrangements or directions are the same on all animals. Head is the anterior, posterior is toward the tail. Okay, so we're going to try to get inside here and see some of the internal organs. These are going to be very different from how people are made, but not so terribly different. So this is a coelomic arrangement. It's a tube within a tube, intestinal tube inside, the integumentary system on the outside. And so you've got that same arrangement in all organisms once they reach or go past sponges, I guess. So you've got that same coelomic arrangement. So we're going to try to get inside of here and see all the organs toward the front. And I would like for you guys to get a drawing of this when we're done. I'll try to take some photographs so that you get a nice drawing of everything that's going on. And I'll zoom in occasionally as necessary. This little next piece is not easy. So this is that tube and tube arrangement, the coelomic arrangement. And what we have is a very tight quarters, I guess. So once I start cutting, I'm going to be trying to go through the skin, but not into the intestine. As you know, with earthworms, these guys are crawling around in the dirt and they're eating constantly. So their intestines are full of dirt, and I only want to cut the top. I don't want to get down into the intestine or we'll have a field full of dirt to work with. So I'm going to try to be delicate. It's not an easy cut. It's a simple cut, but it's not an easy cut. So you have to get inside there, get under the skin, get under the cuticle around the skin. Skin's really important for earthworms. If you see an earthworm on a hot sidewalk, that earthworm is in danger. They need to stay moist because they're constantly exchanging gases across that skin. And so if that dries out, they can no longer do that and they suffocate. So you gotta stay in moisture if you're an earthworm. And maybe that's why you see them out after rains a lot, especially at night when it's nice and cool. Okay, so I might have hit the intestine there. hope not. Moving forward bit by bit. Trying to stay away from the intestines. It's not an easy cut. If you're doing, oh, I definitely hit it there. There's some leaked out. Okay, if you're doing this with a razor blade, you're going to have some of the same difficulties I'm having. But if you're careful, you can leave enough things intact to see everything that's important inside here. Now, I'm going to go way to the front because once you get to the front, you get into some really important stuff. I'm going to give this a little flush. Pretty sure I hit his intestine, but we will find out soon. I'm going to try to tease this open. And then again, we're working on his anterior end. And there we go. Oh, that might be blood rather than intestinal fluid. This looks kind of red. Okay, so there's some things starting to show up. I'll try to get you in closer for that. Go ahead and blot that dry a little bit. So it's not quite so shiny and distracting. All right, so you can see those little white things there are seminal vesicles, and they hold semen that the animal uses to reproduce. And those two large objects, yeah, there's some blood there, are his crop and his gizzard. That's part of the digestive system. And then these little black things right here are his aortic arches. That's part of his circulatory system. So reproductive system, sperm. We've got two parts of the digestive system here, the crop and the gizzard. I have to pull those out a little bit better so that we can see them more clearly. And then the black pieces there are the circulatory system, pieces of the circulatory system. So I'm going to pin these back bit at a time. We might have to repin. You know, I don't think I hit the intestine. I think that was just a little bit of blood coming out. So we were fortunate. Yeah, you can see the aortic arch is much better on this specimen than you can on the ones yesterday. All those little black pieces there are his hearts, and he has multiple hearts. They're not exactly hearts. They're essentially just little muscular places that squeeze the blood along. Worms have a closed system, which is kind of cool for something as primitive as a worm. Closed system means that there is a heart and blood vessels. We did hit the intestine a bit. I'll clean that out of there. I do not get a York for this dissection. But we get to see everything. I'm going to go a little further forward because his brain is way up at the top here, right by his mouth. And it's very, very small. You definitely want to see what an earthworm's brain looks like. And there it is. There's that white little patch right there. That's his ganglion. That's what he uses to think. So hopefully you can see that. I'm about as maxed out as I can get in terms of magnifications, but maybe I can get even a little bit more clear whenever it comes time to edit. That little, looks like a sand grain right there. That's just a few nerve cells all together, and they share information among body systems. As you can tell, there's not much thinking going on in a worm. Pretty simple thoughts going on there. Okay, so really, we kind of have what we need. Everything is showing here. I'm going to zoom in as much as I can. let's take a look at what's here. I guess I'll push this open just a tad bit more so you can see the gizzard and parts of the circulatory system. I'm going to cut that just a little bit. There we go. Okay, pin that back and pin that back. Yeah, see a little black right there. There's a little bit of his food leaking out where I've nicked his intestine. You can see that little red line too. That's his dorsal artery coming down from his aortic arches. Okay, so let's look at some of the ways this organism solves its problems in life, aside from being dissected. It's going through the dirt, it's got to get energy, so it ingests humus. That goes through the mouth into this orange structure right here, which is the pharynx, passes down the esophagus, which goes under these vesicles right here, and then it goes to the crop. The crop is really soft, and it gathers the material to be digested, and then it passes it to this gizzard here. Now, if I push on this gizzard, it's hard. It's wreathed in muscle. So once the food goes in here, it gets crushed up and then passed down into the intestine and then down all the way to the anus where it gets passed out. So you've got several body systems at work here. First of all, your ganglion right there, your tiny little dot right there, which is your nervous system. And then you've got the pharynx, and then you've got the aortic arches. Pharynx is going to pass food, so it's part of the digestive system. The aortic arches are pushing the blood around the worm. It pushes it down the dorsal artery and then back up the other side to the ventral side. And essentially that is how it gathers in its blood and circulates it around so it can get oxygen and nutrition and hormones around the organism. These receptacles are full of sperm right here, and they'll, as I said, they're hermaphroditic. So the smaller ones here are the receptacles actually, and they receive sperm from other organisms, and the vesicles here create sperm that they give to other organisms. And because they're hermaphroditic, it's a two-way street. So they're giving and receiving sperm. There's the crop again. There's the gizzard. There's the dorsal artery. You can see the segments. Every single one of the segments there is showing up nicely. And that's where the muscles are embedded. Okay. And so that's pretty good. I wanted to show you one more thing. I managed to push back the intestine just a little bit, and I'm hoping you can see this next part. But up underneath the intestine, there's a little cord, a little white cord. And that's his nerves. That's his ventral nerve. And if I pass an object over that, like a needle, it makes almost like a small little ticking noise. Nervous tissue is really, really strong. It's got a lot of connective tissue. There it is right there. So that's the same kind of tissue that you would have in you. Your nerves would not look tremendously different from that. And they're also similarly tough. So when I pass that needle over that nerve, it makes a little tick, a little vibration. You can tell it's pretty strong. Okay. All right. So those are some of the major features of the worm, some of the major body systems of the worm. And next week, we're going to try an invertebrate with an open circulatory system, which is the crayfish.